Welcome everybody to my LeetCode Weekly Contest 398 livestream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few moments, we'll be starting our contest live. We'll be answering chat questions live to clarify the questions and give some smile hints. No code will ever be shared, but if you stay around after the contest ends, we'll go through the answers for all four questions. So hopefully we all get to learn something together. I live stream every weekly contest when there's no bi-weekly contest, and bi-weekly contest if there's one. So come join us every week and code along with me. This is Alex does LeetCode. As usual, if you enjoy LeetCode content, be sure to check out my channel. Throw me a like and subscribe to stay up to date on new videos. Alright, so let me see who's around. So I see 4 people in the chat. My mouse is going haywire for some reason. Okay, hello everybody, and welcome. Let's make sure the chat is working. Alrighty, so it's about 9 more minutes to the contest starts. So I've been doing this thing where I come in a little bit earlier and I work on a daily problem. So today's daily problem is hard. So maybe we'll get some warm up in, get our steps in before the actual contest. I'm actually curious how many of you guys follow the daily problem. So I've been doing it quite religiously. I'm at 83, so my streak is 83, which means I'm almost at 3 months now. And before I broke my streak 3 months ago, I had a pretty decent streak going. So I'm curious if you guys follow the weekly problems. They tend to be a little bit better because they're not as tricky and puzzle-like as the contest problems. And most of them are actually fairly easy, so you can figure out quite easy. Oh, actually, I solved this before. Let me see. Undirected tree with nodes numbered 0 to n-1. Hey, thank you, Itach. Yeah, I remember you from last week. Yeah, so this week I'm giving I'm still giving hints, but I'm trying to be a little bit more milder with the hints. So people get a chance to try things on their own. But welcome back. Thank you for the much love from India. Yeah, I would love to visit India someday. It's a very interesting and very ancient country. I just don't know where I should go. Whether I should go just to New Delhi or I should go to some cities in the south. Yeah, I'm curious. I don't know much about India. Let me see. There exists an undirected tree with n nodes numbered 0 to n-1. You're given a 0 index 2D array of edges. Blah blah blah. Okay, standard tree. Okay, so Alice wants the sum of values in 3 nodes to be maximum. You can choose any edge UV, connect the nodes U and V, and update their values. U equals to U XOR K. What the heck? And V equals to V XOR K. Return the maximum possible number of sum of values Alice can achieve by performing the operation any number of times. Okay, so basically you at any point you can pick like any 2 pairs and then flip them. And then you perform another 2 pair and flip them again. And this one will go back for, double flip, it becomes 0. It becomes 0. Okay, so the idea here is you can flip them as many times as possible. You can XOR K, and the way XOR works. Oops. So we're doing like XOR K. The way XOR works is I forget the name for it. It's like reflexive, I think. Like you apply it twice. Two x, it cancels out. And you get back the... So you apply XOR twice, you XOR k twice, it cancels out, and you get back the original one. So essentially, what this means is that when if you XOR this two, and then you XOR this two, 0 will cancel out. And it ends up being a XOR of this one and this one. Okay. So the idea here is you want to XOR. Let me see. Not to put pressure on anything, but please try to stream out the contest. I would try. So I only have time to stream one contest every week, but I think I definitely stream every week. Yeah. So either the bi-weekly or the weekly. Bi-weekly tends to be more popular. There are about 50% more people show up for the bi-weekly contest. Weekly contest is slightly fewer people, because I think bi-weekly is at night, right? It's like 8 p.m. and then weekly is like 8 a.m. No, for you guys, so nobody shows up. To explore India, you should start with Delhi, then Rajasthan. Oh, I don't know about Rajasthan. And UP is what? Uttar Pradesh? Okay. I gotta check it out. Yeah. One of my dream vacations is to go to an Indian wedding, because I heard that Indian weddings are a real festival. I have a lot of Indian friends, but they never invite me to their wedding, or they have wedding in America, which is not useful to me. Okay, so I think this question, I actually remember solving this question. So the first thing to know is that you want to XOR as many. The first thing to know is that the graph is fake. The graph is fake. The graph tells you that you can XOR pairs of nodes, but this is not actually true. You can actually XOR any node, any two nodes you want, within the same connected component. And because it's a tree, right? I think it's a tree. Because it's a tree, all the nodes are going to be connected. So the graph is actually fake. Like for instance, this one, you think you can only XOR, adjacent nodes, but that's not true. If you want to XOR like 1 and 3, just XOR 1, 0, 0, 3. Then 0 will be XORed twice, and it will revert back to its original value. Only 1 and 3 will be XORed. So that's the first thing to know. So the graph is fake. You can choose any two nodes and XOR them together, and XOR both of them. So the idea here is you want to maximize, right? So basically, for all nodes, I'm just gonna say what I think the strategy algorithm is, because this is not part of the contest, right? So there's no giving away answers. For all nodes, figure out if it is bigger if you XOR or don't XOR. If the number of nodes that get bigger after XORing is even, then you can just XOR all of them. If not, then, because every time you XOR, you have to XOR two numbers, right? You cannot XOR just one. So you have to XOR, just don't XOR the one with the smallest delta. I think that's the way to do it. Hey, welcome. 50 seconds contest start. Yes, I am on board. All right, 31 seconds, like this scary countdown. Okay, so once again, reminder, I won't be sharing my screen with code on it. But if you need help, just type in the chat and I'll be there. Yeah, because normally I'm on the other tab. 40 seconds. Let's go. Yeah, come on. Let's go. Let's go. 6, 5, 4, 3, 2, 1. Alrighty. I'm normally on my other tab, so if you have questions, just type in the chat. But I won't show answers, right? Because it's still a contest. Array is considered special if every pair of its adjacent elements contain two numbers with different parity. If num is a special array, otherwise answer false. Okay. Okay. Special array. Special array 2. Consider special if every pair of its adjacent elements contain two numbers of different parity. 2D. Wow. 2D numbers. Oh. Okay, so far nobody has questions. I see 13 people in the chat. Welcome, welcome. Remember, if you have questions about, questions about the questions, feel free to ask. I think question 1 and 2 are both quite self-explanatory. Question 2 is, it's worded confusingly. 0, 4. No questions? No questions. Okay, cool, cool. Let me see. Hmm. Start. Alrighty. Phew. Question 2 done. the sum of a digit difference between all pairs of digits in this. How to approach question 2? Oh, Cam I. Oh, I recognize you, Cam I. Welcome back. So we're not going to share code. We are not going to share code in this place, but I will give you some hints to help you with question 2. Okay, so first of all, can you tell me, Yep, getting a TLE, that's correct. Yeah, it means you're on the right track, but you need something a little bit extra. So I explained the basic one first to get to the TLE, and then I'll explain how to get rid of the TLE. Okay, so let's take a look at question 2. An array is considered special if every pair of its adjacent contain two numbers with different parity. So you're given an array like this: 3, 4, 3, 4, 1, 2, 6. Okay, and then you're given query. The query is from something to something. So 0 to 4, and this is inclusive. So 0 to 4 means 0, 1, 2, 3, 4. 0 to 4. So this is inclusive. Okay? So this is inclusive. And you're given a whole bunch of queries like this. 1 is to 3, 2 is to 4, etc. Right? So if you do the naive thing, which is you do the same answer as problem 1, but you repeat it many times for all these queries, you're not going to succeed. And the reason why you can't succeed is because it's too slow. So you need something smarter, right? You need something smarter. So like one way you can do is every time you see a query, you start from beginning, right? You go from 0 to 4 and you test, is this a special array or not? But you do that, it's going to be very slow. So one thing you can do is, instead of trying to check, look for numbers with different parity, why don't you just go through it once and you highlight all the, I call them problem areas, the problem spots, right? So the problem spots are here, 2 and 6. Any other problem spot? No other problem spot, right? Does that make sense? So it's, wow, sir, tell a little faster. Wow. The attitude. Yeah, I'm just kidding with you. So essentially what you want to do is you don't want to go through this array a bunch of times. You just want to go through it once. And when you go through it once, you want to identify all the problem spots. So problem spots are places where the two numbers side by side have the same parity. So this would be a problem spot. So you can say maybe 3 to 4. Let's just say 3, right? 3 is a problem spot. So now you know, as long as these guys, none of these guys contain 3, you will be fine. Yeah, you will be fine. So 0 to 4 contains 3, right? This will be false. 1 to 3, it contains 3, but it's inclusive. So 0, 1, 2, 1, 2, 3 is up to here. So even though 3 is a problem, 3 is only a problem with its next element, 4. So this is okay. So 2 to 4, does it contain 3? Yes. So this will be false. So having a list of problems will help you go through this array much quicker. Will help you go through these set of queries much quicker. So you don't have to restart from the beginning every single time you see a new query. Okay? So give that a try. Give that a try. Now, there's a catch though. I just want to briefly mention the catch, which is, what if every number here is a problem spot? If there's a lot of problem spots, 4, 5, whatever, all are problem spots, then what you do? Well, in that case, you need to use some kind of binary search. And I'm going to leave you to figure out how to do that yourself. So try to get to this first. Try to get to the first part first. Okay? That's my light hint. So today we're giving light hints. See if you can do the first part first, which is, instead of going through the whole array, every single query, identify what the problem spots are, or the problematic numbers. That's pairs that are the same parity side by side, and then use that to help you. See if you can do that. That will make your program a lot faster. And then we can talk about how to make it even better. And you get stuck, of course, at the end of the contest, right? Try to struggle through first. At the end of contest, I will go through all the questions in depth. So make sure to hang around for that. Let me just read the chat real quick. And last, for parity, check if the values. Oh, so like some kind of prefix sum. Huh, interesting. Oh yeah. Yeah, no, that's pretty smart. I didn't think of that. Yeah. So it sounds like some kind of prefix sum. So I think that will work too. Yeah, that's really smart. Yeah. So thanks, Sarab Kumar Yadav. Ah, damn it. Hmm. Still not able to solve question 2? Give it a try. Tell me about. So I don't want to give like the answer straight up. I'm trying to be more gentle with the hints. So tell me where you got stuck. Do you manage to do the first step where you identify the sort of problem spots? Are you getting a TLE? Are you you getting a TLE, or could you not get the answers at all? Yeah, tell me more about this. Okay. Oh, I'm actually making pretty good time here. Shockingly, I'm able to get to question 4. Let me read this. First, identify all the culprit spots. Yep. And store them in the list of arrays and apply that list. Yeah, got TLE. Okay. If you got TLE, then probably what you want to do is you need some kind of binary search. Yeah. If you got TLE, I assume you got pretty far. So the problem with that I think what's happening is you might run into an array. Let me open up a new one. You might run the array that looks like this. 2, 4, 6, 8, 10, 12, ... Okay? And then so your problem spot, your problems equals 0, 1, 2, 3. Yeah, basically the whole array is problem. The whole array, nobody is good. Everybody is naughty, right? And then what happens is if you get a query that is like 100 to 200, then you're TLE right away, because you have to go through the whole list here, right? Or maybe more realistically, probably like 10,000 10,000, 10K to 20K, some big number, then your TLE right away. So what you want to do is you want to do a binary search. So for the start here, you want to find where the start is in the problem spot. Let's say, you do this very long list of problems. You find, let's say the start is like here, and then the end is like here. It means that there are some problems inside this range. Okay? Conversely, if your start is here and your end is like in the same one, then it's okay. Does that make sense? Yeah. I hope that's helpful. Basically, so probably what you're doing is you're going through the list of problems and you're trying to see if they fall inside the range, right? So instead of doing that, you can do a binary search for the start and end of the range on this list of problems. So another way to do it is actually what Sarab mentioned in chat, which is you do some kind of prefix sum. You do prefix sum of your problem spots, and you go to start and end, and you see how many problem spots are there before start and before end. If there's the same number, that means there are no problems. Yeah, there are no problems. Then you're good to go. Yeah, actually the prefix sum is actually quite smart. It's probably the better way of doing it, I think. Shucks, I lost my... I didn't know they'll do this to you. Okay, anyway. Okay, cool. So question 1, intuition. Okay, excellent. Question 1. So question 1 is... Oh, there are 50 people in chat. Welcome. Welcome, Zephyr Zeshan. Question 1. An array is considered special if every pair of adjacent elements contain two numbers with different parity. So for instance, 2, 1, 4, right? So these two are different. So that's good. These two are different. One is odd, one is even. So that's also good. Okay? Where something like 4, 3, 1, 6. Okay? So 4 and 3. 4 is even, 3 is odd. That's good. 1 and 6. 1 odd, 6 even. Good. But 3 and 1 are both odd. So this is odd. And this is odd. So that's bad. Okay? Your job is to identify if there are any bad pairs within the nums. So how will you do that? You probably want to go through all the numbers, right? So do you know what kind of loop? What kind of loop will help you go through all the numbers? You need some kind of loop, right? You need some kind of loop to go through all the numbers. And then you have to compare like nums I versus nums I plus 1, right? To check if the parity is the same. And then you need one more thing, which is how to compare parity. Parity means either odd or even. So this one, you can think about it a little bit. If you're still stuck, I'll come back to you later. Okay, I'm going to try and do my own question because I'm making pretty good time here. So maybe I can hope to finish all 4 questions today. Non-negative integer k, there exists a staircase with an infinite number of stairs with the lowest stairs numbered 0. Jump with initial value of 0. Starts on staircase number issue. So stair I in one operation. She can either go down 1 or she can go to I plus 2 to power jump. And then jump become jump plus 1. Wow, interesting. Total number of ways Alice can use to reach stair K. So this is, yeah. Okay, let me see. Zephyr still has a question about question 1. Okay, different parity. Parity means odd or even. So different parity means one is odd and then the other one is even. One odd, one even is different parity. That's what it means. So you can find out whether something is odd or even, right? You can check whether a number... Do you know how to check whether a number is odd or even? Yeah. Yeah, beautiful. So see, you can tackle this. You need some kind of loop. And then every element in the loop, you check with the element in front or behind it. And you check whether they are the same parity. If they're same parity, something is wrong. If they're different parity, then you keep going until you reach the end. Yeah, give it a try. Okay. So question 4, I think is probably a very classic... our best friend. Hey, Swastik, how's it going? Question 3, sure, no problem. Okay. You're given array nums of positive integers where all integers have same number of digits. So no code, sorry. We don't share code on this channel. Because it's a competition. I'll show you the code at the end of the contest, but during the contest, no. And anyway, you want to learn, right? So the best way to learn is to try it yourself first. If you really get stuck at the end of the contest, we'll go through it. So for question 3, nums with positive integer, same number. Okay. So basically the idea is you have 1, 3, 2, 3, and 1, 2, right? Let's say this example. So the difference between this, the difference between first and second element is 1, because there's their digit in the left, in the like 0th column is different. Does that make sense? So the difference between this and this is 1. This is the same, so it's fine, right? The difference between this guy and this guy, second and third number, is going to be 2. Because this is different, 3 and 2 are different, and 2 and 1 are also different. Right? So that's what the question is asking for. Now, notice something. Okay? The intuition here, the first intuition I'm just going to write down, is that the difference, total difference, equals sum of the difference in digits. Okay, so that's the first thing to note. If you want to know what's the total difference of these 3 numbers, all you have to calculate is to look at the first column, find out what the differences are. Okay, between 1 and 2, there's 1. Between 2 and 1 is 1. Okay, that's 2. Right, there are 2 differences. You look at the second column. This and this is the same. This and this is different. Okay, this and this is different. 2. Okay, so total is 4. So the first hints I'm going to give you is don't look at them as numbers. Look at them as columns. So look at the first column. Collect all the digits in the first column. Find out what's the total digit difference for this particular digit. In this case, for this particular digit is 2. This particular digit is going to be 2. And then you add them up. So work with each column, each place in the number independently. So that's the first clue. So second clue is, you can figure out how to calculate this efficiently. Right? So think about it for a while. I'll come back to it if you're still stuck. Okay, let me go back, read the chat. Okay. Yeah, I hope that was helpful. So time limit exceeded for question 2. Okay, so if you use the strategy, I keep losing the picture for some reason when I change tabs. This is so punishing. So if you use the strategy I was using just now, right? The strategy I was using just now with the problem areas. Yeah. So if you use that, the problem. Oh, it's back. Oh my god. I just had to click on it. Yeah, from the problem spot, right? If you're using this strategy, then I think the main thing you're missing is probably the binary search. You need to find a way to implement this binary search, or you can use a prefix tree. A prefix sum. Binary search is about a bit easier, but prefix sum is faster. Yeah. So I hope that's helpful. Okay, I really need to work on my question 4 because I have a real chance of actually finishing this all 4 questions today. So we'll see how. I'm still going to answer chat. Yeah. So no sharing of code. I'm going to ask you not to share any code because again, this is a contest, right? If you share code, that's cheating. And if somebody has the same code as you, LeetCode will find that and you will both get banned. So that's not going to be good. So don't share code directly. You can talk about it. If you talk about it, people will write different code from you and then you should be safe. Ooh, wait a second. Question 4 is interesting. I thought it was a DP problem, but it's not actually a DP problem because K is extremely large. In which case, you cannot use... Yeah, question 4. Yeah. I'm thinking about it too. Jitendra. Okay, let me read the chat. So Cam I not able to solve question 2. No worries, no worries. Try your best. Try your best, right? If you can get something like this what's on the screen, you're doing pretty well already. See if you can figure out the last part, right? If you can figure out this like problem spots and like figure out where they go, that's pretty good already. We can go through the binary search later at the end, after the contest ends. So question 3, sum of digits. Yeah, sum of digits. The first hint is look at each column separately. Don't look at them as numbers. Just look at all the numbers in the all the digits in the first place. So in this case, in this example, will be 1, 2, and 1. Figure out what the difference is for this column, and then move on to the next column. The next column is like 3, 3, and 2. So 3, 3, and 2. So figure out what the difference is. Yeah. So how will you figure out the difference? Well, 1, 2, and 1, right? There's 1. So there's like 2 occurrences of 1, 1 occurrence of 2. Okay. So for this guy at 2, he will basically there's one guy there's one number that's different from him, right? And that occurs once, okay? And if your digit is 1, then there's, sorry, let me backtrack a little bit. If your digit is 1, okay, you have 1, 2, and 1, right? There are 2 occurrences of 1 and 1 occurrence of 2, okay? So if your digit is 1, for all the ones, there are 2 of them. For all the ones, you have one person who's different from you. This one person who's different from you, okay? And there are 2 of you. So you multiply that by 2. So if you're 1, you are a 2 person. Okay, let me change it. So let me use this. There's 1 times 2 and 2 times 3, right? If you are a 2 and there's only 1 of you, if you're 2, there are 2 people with different numbers of you than you. So your diff score is 2. If you're a 3, there's 1 person who's different from you, but there's 2 of you. So it's 2 times 1 equals 2. Okay? And note that this one, it counts everything double because it counts AB and BA. So you have to divide it by 2. I hope that was helpful. Yep. I hope that was helpful, Chirag and Aman Nazim. I will go through the answers, all of them, at the end of the contest. So if you get stuck, hold on to your hats. So question 4, I'm pretty sure it has to do with binary. It's a binary question. Yeah. You take the binary representation of K. Because first you get 1, and then you get 0. And then you get 1, 0. Okay. So question 3, let me do that again later. I'm gonna keep the picture up. So the hint is go look at each column individually, and each column you try and do some math to figure out what's the best way. I'm gonna keep the picture up, but I need to work on my own problems, my own contest in question 4. Because I do hope to finish all the 4 questions today, if I can. So sorry I won't be able to get to you, but you're still stuck. End of contest, we'll go through everything. Don't worry. Yeah. I plus 2 times jump. I plus 2 times jump. Jump is 0. So this will be 1, 0. I plus 2 times, and then jump is equals 2. It becomes back 1, 1. 2. Oh, interesting. Yeah, I'm still thinking about question 4. Question 4 is interesting. Okay, so I won't be able to give hints for question 2 and 3 anymore because I've done that quite a bit just now. I need some time to figure out question 4, so work on my own contests. So sorry about that. I'm gonna keep the picture on, so hopefully that's helpful to people. I hope that's helpful to people. If not, then at the end of the contest, we'll go through all the questions. So hold on to your hats. I'm still looking at question 4. Question 4 is interesting. So, every time you jump becomes increased by 1. So, it's kind of a binary problem, I think. So, the maximum number of Oh, I think I know how to solve it. Not sure. Jump minus 1. For question 4, I'm pretty sure it's a binary question. You take the binary representation of k. Start at case 1. Oh, you take the binary representation of k. Okay. interesting. Yeah, sorry. Once again, I'm gonna say not to share code. So don't share code on this channel. LeetCode is very fierce about cheating. So we want to make sure we stay away from that. So sorry about that. Let me come back to you. Give me a few more minutes. Let me figure out question 4 first. Or if not, if somebody is willing to explain, actually, you know what? Let me just do it one more time. So question 3, very quickly, I can't give you detail, but the first hint is treat each number. Don't treat them as numbers, treat them as a collection of digits. Look at each digit separately. So calculate the difference for all the 1 digit and calculate difference for 2 digit, and then so on and so forth, and then sum them up. So difference for 1 digit, you basically count how many times a certain number appears, and then you do some math. So there's a hint there. So for instance, in this example, 3 appears twice. There are 2 3s, and there's 1 2. Okay. So if you're a 2, there are 2 people who are different from you. So you say 2. If there are 3, there's 1 person who's different from you, but because there are 2 3s, you multiply that by 2. Okay. Yeah, that's all I can say for now. I will come back to it at the end of the contest. So sorry about that. Hang on to your hats. I want to finish question 4. I think I know what the answer is for question 4. I think I have a strategy. So if I'm able to finish question 4, I'll come back to you. So hold on to your hats for a while. They are if the No problem, Do Dragon. It's my pleasure. Vinayak Yojoshi. Sorry about that. You're probably missing the binary search. I'm pretty sure you're missing the binary search or prefix sum. I will go through the answer at the end. Huh, interesting. Question 4, I'm pretty sure is a binary question. So the way I'm doing it, and this is again very light hint because I'm still working on it, is to convert k to a binary number. So that's the first thing. Not convert, you don't have to convert, but you have to think of k as a binary number. And you notice that your operations, basically you're doing sum of, like 2 to the power of jump is basically a binary, right? Because jump plus 1 each time. And then you're doing n number of jumps and a number of jumps and b number of minus ones. So that's how I'm tackling it. So for instance, you can calculate when jump equals to 0, you only jump 0 times. Yeah, when j equals to 0, when you jump 0 times, what is the value of that? How many times do you do the minus 1? Yeah. I'm still working on the math myself, so the contest is still live. That's right. Please don't post any code in this channel. Please don't post any. I'll go through that. Sorry about that. Let me finish my own contest first. I really want to do that because I'm pretty sure I know what the answer is. For question 4, jump once. So jump starts from 0. So 2 to the power of 0 is 1. Jump once equals to j. Okay. D equals to K minus J. Oh, shit. Damn it. J plus 1, choose D. Oh! I got question 4. Nice. Alright. Cool. Ah! I'm so happy. I'm sorry, guys. I just want to celebrate a little bit because this is the first time. This is only the second time I did all 4 questions within the time limit in the contest. This is the second time my entire life. Well, I mean, I've been doing this for 3 months. So I've done maybe 12, probably about 12 or 10 to 15 contests. This is the second time I've managed to finish all 4 questions. I'm super happy. I'm super proud of myself. Yeah. Okay, cool. Let me get to the chat and let me see if I can help people. Yeah, thanks. All right. Let me see. What's the one that people ask for help? Question 4. Question 3. Let me start with question 3 first. So I will give a hint for question 4, but I'm going to give a very light hint because, you know, I want to be fair to everybody. But if you do want to know the answer, I'm going to go through all the answers at the end. So question 3. Sum of digit difference of all pairs. Okay, let me explain the question first. What is digit difference? Digit difference means between 2 numbers. Digit difference between 2 numbers. Let's say 1, 3 and 2, 3. Digit difference is you look at each digit and count how many digits are different. Alright? So between 1, 3 and 2, 3, this is different. Right? So 1 digit is different. This is the same. So only 1 digit is different. So if the number is 1, 2, 5, 6, and the other number is 2, 2, 4, 6, then this and this are different. So the digit difference is 2. So that's digit difference. Okay? So let's get back to the question here. So in question 3, you're supposed to count the sum of the digit difference for all pairs of integers in nums. Right? So my hint for you, my first hint is look at each column separately. Don't think of them as 3 numbers or 10 numbers, right? Think of them as 10 times everything in the column. So you look at 10th place, you count the digit difference in 10th place, and then you sum them up and you add 2 digit difference in 1 place. So look at each column differently, right? That's the first thing. Second thing is you want to know Okay, I'm going to ask you not to share any code. Hey, let me see. Dang it. This is never a fun thing to do. I'm going to ask you, so sorry, Rexton George, I'm going to ask you not to share code in this channel. Yeah. Hey, Rexton George, I'm so sorry I have to delete your code. I can't share code in this channel. I'm gonna get in trouble. Alright? So in this channel, we want to help people learn, but we can't share code like this. I'm so sorry about that. I know you mean well, but you know, this is how it's gonna work. So let me finish up on question 3 and I'll go to question 4. So to find out the difference for each column, so one thing you can do is think about it. Let's say there's 3, 3, and 2, right? If you are a 2, if I'm a 2, how many people are different from me? Right? If I'm a 2, there are 2 different people, two persons different from me. If I'm a 2, so there's 1 2 here and 2 different. Let me give you another example. Let's say the digits are, let's say 1 2 2 3 3 3. Okay? So in this case, let's say 4. So there's 1 4, there's 2 2s, and there's 4 3s, right? Yeah. So in this case, if I'm a 4, there are 6 people different from me, and there's only 1 of me, so 4 times 1. If I'm a 2, there are 1 2 3 4 5 people different from me, and there's 2 of us, so times 2. So if I'm a 3, there's 3 people different from me, and times 4. And then you add them up, and you divide by 2, because you're double counting. So that's my hint for question 2. I want to get to question 4. And again, these are very light hints, okay? I'm not telling you the answer. I'm just... Okay, so again, Rexton George, I'm going to tell you not to share code here. I'm so sorry about that. If you do this, I will have to ban you, okay? Do not share code on this channel. I'm very serious, because this is a contest. And we want to make sure that there's competitive integrity. And if people are sharing code here, we'll all get in trouble. Alright? Okay, so question 4. Find number of ways to reach cave staircase. You're given a non-negative integer k. There exists a staircase with an infinite number of stairs, with the lowest stair number 0. So Alice has a jump, right? Jump has 0, and you can jump forward or you go back. And the idea is every time you jump forward, every time you jump, your increment doubles. So at first, initially, jump is equals to 0. When jump equals to 0, you jump 1 step. When jump equals to 2, after you jump once, jump will equals to 1, and then you'll jump 2 to the power of 1, which is 2 steps at a time. When jump equals to 2, you jump 2 to the power of 2, which is 4 steps at a time. You divide by, so Chirag, you divide by 2 in question 3, because the way I just showed you will double count. Try it on your own. I can't give you more hints than that, unfortunately. Okay, so let me get back to question 4. And again, I'm going to ask people not to share code, okay? Don't share code on this channel, and don't share code in general. You want to learn, right? The way to learn is not to cheat in a contest. The way to learn is try it yourself, and you want to know the answer, that's fine. Just wait 15 minutes, okay? So think about it. When jump equals to 0, let's say your target k is 0, right? When jump is equals to 0, Okay, you jump 0 times. How many times do you okay, let me backtrack a little bit. Okay, so now you know how this operation works. Basically, Alice can jump, Alice is going to jump j times, and Alice is going to decrement. This is a decrement operation, right? I equals I minus 1. Decrement d times. Okay? So after j jumps and d decrements, what is the value of Alice's current number? If you do some math, it's going to be 2 to the power 0 plus 2 to the power 1 plus 2 to the power something until 2 to the power j, and then minus d. Okay? When you jump j times and you decrement d times, this is the value of Alice's number. Okay? Which, if you know some math, this is actually equals, and you plus 1. You add the initial 1. And if you know some math, you know that this is actually equals to 2 to the power of j plus 1. This is equals to 2 to the power of j plus 1 minus d. Okay? This is what happens when you jump j times and decrement d times. Okay? So, what do you do here? Well, this is actually very powerful. This means that you can start by saying jump equals to 0. How many possible d's are there? Okay. Let me open up a new one. Okay. So you want Alice to jump j times, and j jumps and decrement d times, right? So if your target is k, when j equals to 0, how many, what's d? When j equals to 0, such that you don't jump, this is the answer, right? D equals to 1. So one way of reaching 0 is to jump 0 times and then decrement 1 time. The other way is to jump 1 time and then decrement, right? This is a jump operation. These two are decrement operations. Decrement 2 times. Okay? And then when j equals to 2, your decrement doesn't work, because when you jump 2 times, your number is too big. The number of times you decrement is at most 1 more time than when you jump. So in this particular sequence, you jump once and you decrement twice. Okay? So the first step is to calculate for each j, what is the d? When you jump 0 times, how many times do you decrement in order to get to the target number? And at some point, for some value of j, your j is so big, the jumps are so big that you can no longer get to there by decrementing, because decrement d is at most 1 more than j. Okay, that's the first step. So same thing for here. When j equals to 0, okay, j equals to 0, d equals to 0. When j equals to 1, that's this, j equals to 1, d equals to 1. When j equals to 2, sorry, no, this is equals to 2. D equals to jump 3. Okay? Okay? So this is the first step. For each value of jump, each number of times jumps, how many decrements do you need? Okay? From here, then you have to notice something. That's the first part. That's the first part, right? The second part is to notice that sometimes you can, when you jump once, okay, this is decrement once. When you jump, let's say twice, and you want to decrement 3 times, there's only one permutation where this works. So decrement, jump, decrement, jump, decrement. This is what's happening here. You decrement, jump, decrement, jump, decrement. But in this case, right, when j equals to 1, and d equals to 1, you can either jump first, then decrement, or decrement first, then jump. This is why there are two possible. These two are both j equals to 1 and d equals to 1. Does that make sense? So first step is to, for each value of j, for each value of jump, right? Calculate how many times you need to decrement in order to reach the target number. And the number of times you decrement is at most one more than the number of times you jump, because you cannot go down twice consecutively, right? That's the first step to calculate this table. Second step is for each of these rows, when jump equals to 1, decrement equals to 1, you need to calculate how many permutations there are. So the permutation is basically if there are like 3 j's, then there are 4 possible places, and let's say you need to decrement twice. There are 4 possible places to put your d, right? So you do a permutation. 4 choose 2. So you'll be dj, dj, j, or j, d, j, d, j, or something like that, right? 4 choose 2. So that's the first part and the second part. So the first part is understand. I guess the first part is figure out what the formula is. The formula to get to get to a target k, right? Is you not need to know the formula is you have to jump some number of times and decrement some number of times. Okay? And you need to be able to find out if you jump j times and decrement d times, what number will you be at? So once you're able to figure that out, then you can do the next step, which is when j equals to 0 and my target is k, how many times do I have to do the d? Right? And then you sort of match. For instance, when target is k equals to 0, j equals to 0, you have to decrement once. When you jump once, you have to decrement twice. If you jump twice, then no amount of decrements will help you. Same thing, when k equals to 1, you jump 0 times, you have to decrement 0 times. When you jump once, you have to decrement once. You jump twice, you have to decrement 3 times. And you jump 3 times, no amount of decrements will help you, because jump 3 times, you get 8. And there's no way to get back down to 1 by decrementing. Okay? So once you have this table set up, each of these rows are basically permutation. It's a permutation problem. So you figure that out yourself. Yeah, I probably said too much already. So good luck. I don't want to give any more hints than that, because I think last week somebody pointed out quite accurately that, in the interest of competitive integrity, we don't want to cheat too much, right? We just want to discuss. So that's why there's also no code policy, no sharing of code on this channel. I purposely left some math for you to figure out yourself. But there's only 7 minutes left in the contest. If you want to know the answer, hang around and try and figure it, and we'll go through it step by step. And if you want, look, there's no prize for winning the contest. There's no prize for winning contests. So your goal is to learn, right? So see if you can use the hints I gave you and then power through them and sort of write the program. So that's my hope. Yeah. Yeah, you don't find the nearest jump. You have to find multiple jumps. If you jump, if you jump 1 time, you jump 0 times, how many D's are there? You jump 1 time, how many D's are there? Keep going until, your jump is so large that you cannot decrement it back down to K. Because your D, you cannot decrement twice in a row, right? It says here. Where does it say? Cannot be used consecutively. So you cannot decrement twice in a row. You cannot decrement twice in a row. Yeah, so that's the first step, is to find what, for each value of J, what is D. And you'll get to a point where the J is so large that D is not valid. Like no valid candidate exists for D. And second step is to solve the permutation problem, which I'm going to let you figure out yourself, right? The hint is here. Look at these two. Yeah. So good luck. What's good? I'm definitely not the #1 LeetCode streamer. I'm hoping the streams are helping people learn. I'm gonna, over time reduce the amount of hints I give, because, like, for instance, today, even question 1, I didn't solve it for anyone. Yeah. So we'll see how things go. But I don't know what's the rank. You only see your rank next week. So this is the first time I managed to finish all 4 questions. So my rank is very low. So once again, if you're looking, I'm not saying that you guys are, but those nefarious bad guys who are trying to cheat should not cheat in my stream, because I'm very slow. So you will not get the answer that you want. Yeah. Was updated in the scoreboard? Let me see what's my rank. 167. Oh, not bad. Not bad. Yeah. Well, this is yeah. I think this is the best rank I've gotten so far. So I'm pretty happy about it. Okay, 3 more minutes. Yeah, I'm not. I don't think it's gonna help to give more hints. I think at this point, either you get it, you're on your final legs trying to solve it, or you don't. So while people are still here, before everybody runs away, I do want to say, that if you like my content, show me a like and subscribe. You can feel free to check out more LeetCode videos on my channel. I do a bunch of LeetCode problems. And if there's other content that you enjoy, just let me know. And I'll try to include them, because I feel like people don't always want to just watch like an answer video. Sometimes it's a little bit boring. They only watch it if they are trying to solve the problem and they look for the answer. Hi, Rohan Sharma. Welcome back. Were you in the contest? I didn't see you in the chat just now. I see you every week, Rohan Sharma. Yeah, 2 more minutes. 1 test case failed. Which one are you working on, Zafar? You're looking for the first one? Okay, cool. If length equals to none. Yeah, so sorry, Rohan. It's like 8 o'clock, right? 8 a.m. It's terrible. Oh, man. So, it's array, Boolean array. Yeah, so Zephyr, Zeshan, if you're close, let me see, 1, 4, and 0, 1. Oh, it might be off by 1 error. I think you might have an off by 1 error. because you're finding the culprits. Yeah. I'm going to. Is it bad for my career? It's not bad for my career. YouTube is not my career. I'm just doing this for fun. But I don't want. So the rules in this channel is no sharing of code, no matter what, during the contest. I'm also going to try and reduce the amount of hints that I give people, so that it doesn't seem unfair. And then the third thing is, because I'm not ranked very highly, so even like, look, if you cheat off me, you're not gonna get you're not gonna get in the leaderboard, right? So I'm not the right person to cheat off. Yeah, but I will reduce the amount of hints I give people. So I might just say, oh, think about a DP, or think about using a tree here, because it's still a contest, right? So we want to make sure we're sort of fair to everyone. At the same time, I also want to make sure people learn from the process. I think if I just discuss answers at the end after the contest, people are less interested and less likely to want to hang around and find out. But write in the code, whatever you guys want, write in the code. Write in the comments in one of my videos, and yeah, reach out and let me think about what's the best way. Yeah, but it's definitely not bad for my career. Can you solve Q4 of previous contests? I have to look it up. Which contest? Bi-weekly or weekly? Okay. Okay, while you're there, I'm just gloating here, man. While we're there, let me take my sip of water, and then we're gonna go through all the questions, okay? Real quick, be right back 1 second. All right, once again, can we start with question 4? Let me just go through question 3, 1, 2, 3 quickly. So once again, thanks for coming up to contest. I hope that everybody did well, at least up to your own standards and definitions of well. The truth is, if you come back week after week and you participate and you learn something, you're already a winner. So don't worry about getting a rank or anything like that. That's secondary, and definitely do not try to cheat. Yeah, I'm going to be tougher on that in the coming weeks. Okay, cool. For people on YouTube, we are discussing solutions for LeetCode Weekly Contest 398. Jump to specific questions using timestamps in the problem video description. And please check out the rest of my channel if you enjoy LeetCode content. Like and subscribe to stay updated on new videos. Okay, cool beans, cool beans. I'm going to be quick on the first couple of problems, so that we have time to do 4. Okay, so question 1. Question 1, an array is considered special if every pair of its adjacent elements contain 2 numbers with different parity. So different parity just means odd and even. And if you want to check whether it's odd and even, the array has odd and even, this is fairly straightforward. You just do a for loop, and for each element, if you want to check what its parity is, you just divide it by 2. You take mod 2, divide it by 2, find its remainder, right? And in this case, I check against the number just before it, I minus 1. You can also check I plus 1, in this case, you have to start from 0 and go to length minus 1. So I start from 1 and go to length. Okay? If you find something, that's a false. If you don't find anything, it's a true. That's all there is to question 1. Okay, question 2. Special array 2. An array is considered special if every pair of its adjacent elements contain 2 numbers with different parity. So it's the same thing. Basically, it's the same thing, except now instead of one query, you're given multiple queries. These queries are in the form from to. So you're not checking the whole array, you're checking part of the array. Okay? You're not checking the whole array, you're checking part array. So for instance, in this example, if your query is 0 to 4, okay, 0, 1, 2, 3, 4, because 3 and 4, these two numbers are the same parity, that's a fail. Okay, so the way to do this, if you just do it naively, for every query you just go down the line and check, you will get a TLE. This is very slow. Is basically n squared. It's n in the length of this array and n in the number of queries. So that will give you a TLE guaranteed. So the way to make it better is step 1 is to find these, like I call them in the stream, I call them problem areas. So you only go down the array once, and as you go down, what you do is you find these problem indexes. A problem index is an index who is the same parity as its next number. So in this case, the problem index for this example, there's only one problem index, and that is 3. 3 is a problem because 3 and 4 are the same. Yeah, 3 and 4 are the same parity. They're both even numbers. Okay? So once you have this set of problem index, now you can go through the query, and now you're working with a much smaller set. For each query from start to end, you just look and you see whether any problems exist inside that range. Okay? So there's still a catch though. There's still a catch. What if the whole array is problematic? So what if the whole array was like this? 2, 4, 6, 8, 10, 12. Then your problem spots is basically everybody. Then that becomes very slow again. So in this case, what you want to do is you want to do a binary search. So let's say your problem spot is your list of problems is very long. Then what you want to do, and somebody asks you, let's say 100 to 150, does it contain any problems? Well, what you want to do is you want to do a binary search. That's where the binary search comes in. So in Python, the way to do it is using this thing called bisect. So what I do, you see, I did this problem, this bad. Okay, I did a bisect, and you can see I actually tried the naive method first. It doesn't work. So bisect left, bisect L is the start, and then bisect tells me the index for the n. And if left and right are the same index, it means that they don't contain any problem spots between them. I'm good to go. If not, then there's a problem, right? So this is question 2. Let me see if there's any questions. Oh, sorry. I thought I was sharing my screen. Was I not sharing my screen? Contest discussion thread. Yeah, I should do that. Yeah. Well, you know what? If you guys like my content, I would be grateful if you guys post in the contest discussion thread. Yeah, I don't know. But the thing is, if I do that, then I know there's a lot of people who will come in and try to cheat. I think my audience is, you guys are really nice people and you're very honest people. So I kind of want to like to keep it that way. You know, I don't have to be a big streamer. I just have to be a small group of good audience like you guys. Is maybe more fun. Okay, so question 3. Sum of digit differences of all pairs. You're given an array nums consisting of positive integers that have the same number of digits. Okay? Difference between two integers is the count of the different digits. So between 1 and 3, for instance, 13 and 23, this 1 and this 2 is different. So this is one difference. This 3 and this 3 is the same, so no difference. So the digit difference between 13 and 23 here is going to be 1. Right? 13 and 23 is 1. Between 1,256 and 2,246, well, this thousands place is different, and the tens place is different. So the difference between these two numbers will be 2. That's what digit difference is. So how do you calculate digit difference? The first step is, the first hint that I will give is look at each digit separately. Look at each digit separately. You look at all the digits at the same time is a pain. So you want to look at each digit separately. So for instance, in this case, you want to look at all the tens digits first. Calculate the sum of all digit difference between all these numbers, all these pairs, and then which is 2, and then the sum of digit differences between all these numbers in the ones place, which is against 2. You add them up, you get 4. Okay, so total number of diff equals to sum of the diff of the different digits. That's what this thing is talking about. And how do you find out the sum of the different digits? Well, look at this way. That becomes a math problem. So consider this example. Let's say you have these numbers 4, 2, 2, 3, 3, 3, right? You want to find all the sum of differences. Well, let's think about it. The first thing I want to do is to count how many occurrences there are of each one. So there's 1 4, there are 2 2s, and there are 4 3s. If you're a 4, everybody is different from you. So all these 6 people are different from you. So if you're 4, your digit difference is 6. Okay? And there's 1 of you, there's only 1 4, so there's 6 times 1. If you're 2, your digit difference is everybody who's different from you, 1 and 4. So that's 5. And there's 2 of you, so times 2. And that's 10. And with your 3, there are 4 3s. For each of the 3s, how many people are different from them? Well, there are 3 people from them, different from them. There's 1 4 and 2 2s. Right? If you're 3, this guy, and this guy, there are 3 people different from you. If you're this 3, then your other 2 3s, they are not different. Right? So 3, and because there are 4 3s, so 3 times 4. Okay? And you notice that you have to divide this number by 2. Why? Because you're counting the differences between 3 and 2, and then between 2 and 3. So A and B, B and A. So you're double counting. Whereas if you look at the example, they count the difference between 13 and 23. They don't count the difference between 23 and 13. So they don't double count. So what we're doing there is double count. You divide by 2. So the code actually looks something like this. Okay. So you do a count. Count is, just count frequency. That's all that's happening here. You do count of frequencies. And then after that, what I do here, this is a source. This is a secret source that implements this. So for each count, let's say this 4, I do count times n minus count. So there's 4 of us. There's 3 people who are not us. So 4 times 3. And then you sum everything and divide by 2, and that will give you the answer. Okay? Let me check if there's any problems. If not, we'll go on to problem 4. What do you use to write on the screen? I use a Chrome plugin called Page Marker. Yeah. Try question 4. Yeah, try question 4. Good. I'm happy for you, Kemai. Look, if you're learning, then you're winning. Right? Okay, so question 4. Question 4 is a hard one. Find number of ways to reach the cave stair. You're given a non-negative integer k. There exists a staircase with infinite number of steps. The lowest stairs numbered 0. Alice has a jump and an initial value of 0. She starts on stair 1 and wants to reach stair k using any number of operations. She is on stair 1, stair I. In one operation, she can go down 1 step. This is a decrement. Okay, or she can do I plus 2 to power of jump, and jump is increased by 1. So this is jump. Okay, return the total number of ways Alice can reach stair K. So she's trying to get from here to here. She can jump, 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 and then she can go back and then jump some more, and then go back and then jump some more, right? That's what she's doing. Okay, cool. So for instance, when K equals to 0, she can start at 1. She can go down 1 step. From 1, she go back down to 0. Okay, to reach that 0. Or from 1, she can go up. She can go up 1 time to 2, and then go back down to 0. Yep. So those are her options. So how will you do this? The first thing, the first thing I try to do is dynamic programming until I saw this 10 to power 9. No way you can do dynamic programming. So the way to think about it is, think about it this way. There are 2 operations, right? Let's say you jump j times and you decrement d times. Okay, what will be the value of Alice's position? So if you jump j times, the first time you jump will be 2 to power of 0 plus 2 to power 1 plus 2 to power of 2 dot 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 until 2 to power of j minus 1. Okay? And then you plus 1 because Alice starts at 1. She doesn't start at 0. And then you minus d. Okay? So if Alice jumps j times and decrement d times, this is her value. Okay? And if you know some math, you can actually simplify this. This thing simplifies to 2 to power of j plus d. So if Alice jumps j times and decrements d times, she will be at 2 to power of j plus d. Okay? So the question says, for each value k, how many ways does she have of reaching k? Well, let's check for each value of j. Let's say k equals 0. When j equals to 0, you don't jump any times. How many ways are there of reaching 0? Well, you decrement once. Here. When stack is at stair 1, what do? You had decrement twice. Okay? So the first step is for each value of j, calculate what's the value of d. And you can do that by using this formula up here. 2 to power of j plus d equals to k. So when j equals 0, d equals 0. When j equals to 1, d equals to 1. When j equals to 2, d will actually equals to 3. Okay? That's what's happening here. J equals 2, d equals to 3. Okay? So at some point when j equals to 3, what happens to d? Well, when j equals to 3, this is 2 to power of 3 is 8. And d, you cannot decrement enough times to bring d to k. Because you know that d can at most be 1 more than j. Yeah? Okay, so what do you do here? This is step 1, right? Step 2 is, notice this thing is very interesting. When j equals to 1 and d equals to, when j equals 0, d equals 0, that's fine. When j equals to 2, d equals to 3, there's only one possible permutation for this. She has to decrement, jump, decrement, jump, decrement, which is what she's doing here. Decrement, jump, decrement, jump, decrement. But when j equals to 1 and d equals to 1, she can either jump, decrement, or decrement, jump. Okay? So this is the second sort of key to the puzzle. The first key is for each j, you have to find out what the value of d is. The second key is know that d is actually a permutation. So for instance, if j equals to 3, there are 4 possible slots for d. And if d equals to 2, then you can do d here, or d here, or d here, etc. Right? So this is basically 4 choose 2. This is a permutation problem. Okay? So that's how you solve this problem. And I'll show you my code. Actually, it's like shockingly short. I didn't realize how short this was. So the first thing I did is I calculate what's the largest j I need. So the largest j I need is basically math log 2k. Yeah, it's just log 2 of k. I calculate n, I add 3 to it because, you probably need to add 1, but, or 2, I'm not super sure, but I just add 3 just in case I was running out of time. Then next thing I do is I calculate j to the power of, like this 2 to the power of j plus d. Right? So 2 to the power of j, this is 2 to the power of j. Actually, I don't even need this. And then d equals to this. Yeah, it's jr this jr is 2 to the power of j minus k. And then the next thing you want to check is if d is smaller than 0, you cannot do d less than 0 times. Your j is already too big. Or if d is larger than j plus 1, you cannot decrement that many times. You just cannot decrement that many times. Then you continue. If not, then you do this combination. You do n choose d, where n is the number of spaces available, which is j plus 1. So j plus 1 choose d and return count. You run this would accept, and it's actually super fast. Why do you stream during contests? I mean, if people are cheating outside my stream, then they're gonna cheat whether I stream or not. Right? So if they're cheating outside my stream, I mean, I look, cheating is a problem for sure. But if they are cheating, outside my stream, they don't need my stream to cheat. They will be doing it no matter what I do. But inside my stream, so you do have a valid concern. I don't want to pretend like you're wrong. I do agree with you to some degree. But within the stream, we make sure that there's no sharing of code. And I try not to give the most. I try not to give the most so much hints that it becomes obvious. So I try to give hints gently, right? Yeah, but Roger Dogger, I'm not gonna deny your stance. I do think that you have a valid point. And I'll think about how I can make this better, because at the end of the day, it's also my community. I want to make sure that people are learning, and if people are cheating, then it's not helpful. Yeah, but I will. Yeah, I mean, if you can tell me who's sharing code or who's cheating, then let me know. I will definitely take action against them. Yeah, and I actually do appreciate your comments. Okay. Did not understand question 4. Question 4 is kind of hard. So you need to know both the math and you need to know a bit of programming. So if you can't get question 4, it's a hard problem. Don't worry about it, right? As long as you can get earlier questions and you learn something from the contest, that's the most important thing. Yeah. Yeah. So we will take a fairly strong anti-cheating stance. There's again no code sharing. I'm also gonna make sure that I don't give. Yeah, I'm trying to reduce the amount of hints that I'm giving. So this way, people don't feel like they get an unfair advantage. And plus, to be very frank with you, I'm not like a top screener. I'm not like on the leaderboard. So if you come here, if you're trying to cheat and you come here, you're not gonna get very far, right? This is not a place where, yeah. Okay, so I'll try to do it again. Question 4. It is a bit complicated, so if you don't get it, don't feel too bad. So the basic idea is you recognize that. Yeah, the basic idea is first identify that if you jump j times and you decrement d times, you'll end up here. If Alice jump j times and decrement d times, actually it's not plus d, it's minus d. Yeah, it's 2 to the power of j minus d. Okay, so if you jump j times and you decrement d times, you end up at 2 to the power of j minus d. So what you want to do after that is for each value of j, find out solve the math equation to find out what's the value of d. So for instance, if you jump 0 times, your d is 1 time. You jump 1 time, your d is equals to 2, so you decrement twice. Yeah, the additional condition is d cannot be 1 more than j. It's at most 1 more than j, because you cannot jump consecutively. So what you do is for each value of j, you calculate what's the d. And once you have this, you have to solve the permutation problem. So the permutation problem is basically you have a bunch of j's, and the spaces, there's j plus 1 spaces, and you want to insert the d's between them, because remember you cannot have 2 consecutive decrements. You can, if you decrement once, you have to jump the next time around. Okay, so you get something like this. So the permutation is going to be j plus 1 choose d. Yeah. Once again, if you can't solve question 4, it's not a big deal. It's a pretty hard problem. Think about it a little bit yourself. Play around with it. And if you still can't solve it, write in the comments. I will try to... Yeah, if you really want to know, I can release a video and try to help you. You thought it was a greedy problem? Oh, dude, at first I thought it was a DP problem, and then I saw 10 to the power of 9. So yeah, you gotta. Yes, it is a hard problem. So you gotta do what you gotta do. So Doe Dragon, can you show me how to train for hard problems? I've attended a lot of contests, but 3 questions is the best I can do. You know what? 3 questions is the best I can do for most contests also. Actually, I can do most question 4s if I spend a lot of time on it. I think, to be honest, programming contests is about recognizing problems and sort of applying the same patterns that you've seen many, many times. So it's some kind of DP, or it's some kind of like prefix sum, it's some kind of math problem. I think, to be honest, the value of doing these really hard problems is not that great. So if you want to learn, you want to become the best programmer possible, then doing the really hard problems probably will not help you that much. It will help you become more mentally agile, and it will also help you become a more competitive programmer. But if you want to be a great software engineer, then probably that's not the right way. Yeah. So I guess my answer unsatisfying answer is don't worry about it if you can't get the problem false. If not, try your best. Okay. So, any other questions? Let me see in the chats. I don't see anything else. But thanks a lot, everybody, for showing up. Yeah, appreciate all of you once again. Doesn't matter what result you get. If you show up week after week and you try and you learn, then you are already a winner. All right. Thanks a lot. That's all for today's stream, and I'll see you next week. Bye bye.